All right, let's stop talking about this stuff. Let's work some problems. That's really the way to learn this stuff. What if you have the integral of negative over the values of -1 to 8, these are the limits of integration, of the function 6, which is just a constant, dx. It's a very simple function because, in fact, it's not even dependent upon x, it's just a constant. What would this be equal to? Well, I just want to remind you that this is the same thing as having the integral of 6x to the 0 power dx, because x to the 0 is just 1. Anything to the 0 power is 1. The reason I wrote it that way was because when you write it this way, I think you'll agree with me that the answer would be 6 over 0 plus 1 is 1, x to the 1 power. So we're using that formula, but we're going to have to evaluate this from -1 to 8, okay? Because it's a definite integral. So it's going to be 6x evaluated from -1 to 8, right? So how do we do that? Using the fundamental theorem of calculus, we evaluate it at the top one first. So that's 6 times 8 minus 6 times -1. Okay? And so this will be 48 minus -6, which is 48 plus 6, which is 54, which is the answer. Now, I want to also point out to you, look how I did this very explicitly. 6 times 8 is in the first one, minus bracket 6 times -1, and I left it like that. I didn't multiply it here. I wrote 6 times -1. I'm going to tell you right now, if you try to be fancy and skip steps and start doing things in your head, you will get the wrong answer. It is a matter of time, especially with the sign errors. So go ahead and take the few lines of paper to write it down exactly what you mean, put your -6 here, and then make it a positive, and then add it together. If you start doing all this stuff in your head, you're going to get the wrong answer. It's just a matter of time. I can guarantee you that. Let's go on to another problem. The integral from 0 to 1 of x to the 99th power, okay, over dx is equal to, we already know how to integrate this. It's 1 over 99 plus 1 is 100 times x to the 99 plus 1 is 100th power. This is just the formula we've used, evaluated from 0 to 1. So this is going to be 1 over 100 times 1 to the 100th power, so this will be times 1 to the 100th power, big surprise, you know that's going to be a 1 in the end, minus 1 over 100 times 0 to the 100th power. So you know this whole thing just goes to 0 because 0 to the anything power is just 0. And so in the end, what you're going to get is 1 over 100, which is the answer, because you have 1 over 100 times 1. 1 to the 100 power is just 1. This goes to 0, so that's your answer. Okay? So what I'm going to do to save a little space, I'm going to say this is equal to 1 over 100, just like we just said, and I'm going to work another problem right underneath here. Okay, now what if we had a problem that looked like this? Integral from 0 to 1 of 1 minus 2x minus 3x squared over dx, okay? And we want to evaluate this guy. Now here we have basically a polynomial. We know how to integrate each part of it, and they're simply added together. So from our other property, we know that we can just integrate each one separately and add up the results. So let's do that. What would we have? For the first term, this is kind of like 1x to the 0 power. So to integrate that, it's going to be 1 over 1 x to the 1 power, because 0 plus 1 is 1, so we get 1 down here and 1 up here. For the next term, you got to carry your minus over. You're going to have 2 over 2x squared. You have an exponent of 1 here, so it will be 2 over, and you have 1 plus 1 is 2, x to the 1 plus 1 is 2. And then over here, you'll have, for the same reason, 3 over 3x to the 3rd power. For the same reason, when you integrate that, it's 2 plus 1 is 3, so that goes into the denominator of that fraction there, and also in the exponent. Now don't forget that we've integrated it, but our limits of integration are from 0 to 1, so we need to go ahead and keep that there. Okay. Now we've done the hard part. We've done the integration. Now to find the answer to this definite integral, we need to use that fundamental theorem of calculus, which says that we basically plug in the top number here into this big long expression, and then we subtract off this big long expression evaluated at the bottom number. Okay? So before we do that, we're going to simplify what we have here a little bit. What you're going to have is x minus x squared minus x cubed, evaluated from 0 to 1. This is what we need to evaluate. So let's do this. For this function evaluated at 1, it's simply going to be 1 minus 1 minus 1. I think you can convince yourself of that. 1 minus 1 minus 1. Anything raised to the power of whatever is 1 raised to the power of anything is just 1. Minus the same thing evaluated at 0. You're going to have 0 minus 0 minus 0. So I'll just write it 0 minus 0 minus 0 so we don't forget what we did here. So in this bracket, I'm going to have 1 minus 1 is going to be 0 minus 1 gives me negative 1 over here. And then I'm going to be subtracting off a big fat 0. So the answer to the problem is negative 1. Okay? Now one thing I just want to point out is that when I do this integration, notice how I'm very explicit. 1 over 1, x to the 1, 2 over 2, x to the 2, all this stuff. You know, in your head, you could simply put a 1 here and a 1 here and try to skip a step, but I like to keep it very explicit so that in the next step you simplify these very simple looking fractions, and then even when I get to here, you could in your head do this, plug this 1 in and probably get the answer, but you need to get in the habit of writing everything out, because then it'll do two things for you. It'll make sure the teacher knows what you were doing so that you can get partial credit. If you haven't totally gotten the problem right, maybe you can get some partial credit. And the second thing it'll do for you is when you're studying for your test, believe me, when you study a semester of calculus, you may not remember some of the earlier concepts when you're studying for your midterm, and having the explicit steps in your homework will really help you out to remember what the heck it was you were doing. So we'll do a similar problem to gain some experience with working with integrals. Integral from negative 3 to 0 of 5y to the 4th power minus 6y squared plus plus 14 integral over dy. Now notice this integral is in terms of y, but I'm integrating over dy, so that's cool. So it's really the same thing as integrating over x and dx. It's just your variable is going to have a y in it. This limit of integration is negative to 0. Well, that would be like, in case that looks a little weird to you, if this is what your function looks like, that would be like integrating from negative 3 to 0. So you would be looking at the area, all this area under the curve here. So don't be freaked out by the limits of integration that are negative. They're just another number that you're going to end up plugging in the end. It's not a big deal. Okay. So in order to do this, let's go ahead and integrate this. You should remember from that other property, hopefully through these examples, what you're going to have is 5 over 5 y to the 5th power. Okay. 5 over 4 plus 1 is 5, y to the 5th power, minus 6 over 3 y to the 3rd. 2 plus 1 is 3, so I've got 6 over 3, and I've got y to the 3rd, plus 14y. Okay, and that's because that's y to the 0, so when you add 1 to 0, you'll get a 1, so you have 14 over 1 y to the 1. And then finally, don't forget that you're evaluating this integral from minus 3 all the way up to 0. So let's simplify what we have in here. I'm going to have y to the 5th power minus 2y to the 3rd power plus 14y. All I did was simplify these fractions. I've done nothing else. And then this is going to go from negative 3 all the way up to 0. Okay? So let's go ahead and evaluate that. If we do that, plug in the top number first. You're going to have 0 to the 5th power minus 2 times 0 to the 3rd power plus 14 times 0. This whole thing is going to end up giving you a big fat 0. And then you want to subtract off evaluating this expression at negative 3. So here's where you need to be a little bit careful. Put your negative 3 in to the 5th power. Make sure and enclose it in parentheses so you know what you're doing. Minus 2 times parentheses negative 3 raised to the 3rd power plus 14 times negative 3. Now notice that I put my negative 3 in parentheses, and that was just so that I didn't get confused what I was doing. If I wrote this, for instance, as 14 times a negative 3, well, if you have a real light pencil mark or something, you might end up looking at 14 minus 3 or something like that, and you might get confused. When you put it in parentheses, it's very clear that you're multiplying these things together. Now, as we said, this whole thing goes to 0. So what I'm going to be left with is negative from this out in front. And I go, keep my brackets here. Now, 3 raised to the 5th power is 243. You can put that in your calculator. And since it's a negative sign, and I'm multiplying it by itself an odd number of times, it's going to be negative 243. You can put that in your calculator and figure that out. Minus 2 times 3 cubed is 27, and for the same reason, because it's a negative and it's an odd number of times, it's going to be negative 27. And you could simply put that in your calculator and prove that negative 3 raised to the 3rd power is negative 27. And then over here, what you have is negative 42. And this is all inside of this bracket here. Okay? So what you'll have, and I'm at everything very explicitly, minus 243 plus 54, which is negative 2 times negative 27, positive 54, minus 42. And then when you do all this and you add it all up, you get a positive 231. When you add these numbers up on the inside and you multiply by negative 1, you'll get a positive 231. That's a positive area. So that's the answer to this integral. Okay, right there. It took up most of the board, so let's go ahead and erase this one and we'll work on a problem of a little bit different type. They're all integral problems, but I'm trying to give you kind of a flavor for the different varieties so that when you do your problems, they won't seem so foreign to you. What if you had the integral from 0 to 4 of the square root of x dx? Okay. Now the first thing I like to do when I have a square root anywhere is write it as a fractional exponent, which is x to the 1/2 dx. The reason I like to do that is because the formula to take the integral is written in terms of exponents. So what would this be? The fact that this is a fractional exponent has no bearing on how you actually solve the problem. It's the same way as before. So what you'll have is, it'll be 1 over, and you'll have 1/2 plus 1 in the denominator, x to the power of 1/2 plus 1. And that's the answer to the integral itself, but you have to remember to evaluate it from 0 to 4, because that was our limits of integration. So this will be 1 over 3/2 x to the 3/2. Now you could have done that in your head, but I was writing it explicitly so you know what I'm doing here. You just add 1 to the exponent, and that's how you get your answer there. And this is evaluated from 0 to 4. So 1 over 3/2 is just 2/3. You just flip it over. X to the 3/2, and this is evaluated from 0 to 4. Okay. In order to finish it off, we just need to plug in 4 and plug in 0. So what we will have is 2/3, 4 to the 3/2, this is times 4 to the 3/2, minus 2/3 times 0 to the 3/2. Okay? Now, I think you can convince yourself that this term is going to be 0 because 0 raised to the anything power is 0. So this term goes away. But this term doesn't. So when we work with this term here, what you're going to have is you're going to have 2/3 times, notice this is 4 to the 3/2. So what this really is 4. Another way to write this, you could simply put it in your calculator, but if you didn't want to do that, this would be 4 to the 1/2 raised to the 3rd power. And I think you can convince yourself of that. When you have an exponent raised to an exponent, you just multiply the exponent. So this is 3/2, which is what we started with. Now I know what the square root of 4 is. This is going to be 2/3 times 2 to the 3rd power, okay, which is 2/3 times 8, okay, because 2 raised to the 3rd power is 8. And so finally what you'll end up happening is 16 over 3. 8 times 2 is 16, all divided by 3. So your answer would be 16 over 3. So you see, it's pretty mechanical. It's pretty mechanical, and it's not too bad. Now, of course, I already told you before that integrals can be quite complicated and difficult to do later on down the road, but I've given you problems that you know how to do, and so that's why they seem so easy. In the not too distant future, you're going to be given integrals that are going to be significantly more difficult to solve. But these guys here, when they're in terms of polynomials or something, is fairly simple. So here you have integral 1 to 3 of 1 over t squared minus 1 over t to the 4th power dt. Now the fact that it's t and dt doesn't really matter in the end. It's all going to be the same. Treat it the same way that we've been treating it. Now what I like to do when I see a problem like this, I've been saying it over and over again, is I like to write these in terms of, instead of powers, write them in terms of exponents. So then this would be t to the minus 2 power minus t to the minus 4 power dt. That's equivalent. That's exactly the same thing. And when I write it this way, it becomes much easier. Now, in order to apply the rule, I do it the same way as I did before. No big deal. 1 over minus 2 plus 1 t to the minus 2 plus 1 minus the second term, which is 1 over negative 4 minus 1. I'm sorry, negative 4 plus 1 is what we're doing when we integrate. T to the negative 4 plus 1. And this whole thing has to be evaluated from 1 to 3. Now, I was very explicit when I wrote that out. In reality, you could probably do this part of it in your head. This is going to be what you see you're going to have here for the first term is 1 over minus 1, right? So that's just going to give you a negative t to the negative 1. And then for the second term, it's going to be minus, but what you're going to have here is you're going to have 1 over negative 3 t to the negative 3. So you have to be real careful to keep your signs right, to make sure that you get it right. So you're going to have negative t to the minus 1 plus 1/3 t to the minus 3. That is the integral. Okay, that's the answer to the integral, but unfortunately we're not totally done yet here because we need to plug in those values there. These values right here. Okay. In order to do that, sometimes it's easier when you're trying to get your final answer to go ahead and flip this back to fractional form. So this is negative 1 over t plus 1 over 3t cubed, evaluated from 1 to 3. And all I did was move the t down in the denominator here and the t3 down in the denominator there. I didn't do really anything more than that. Okay, and we need to evaluate this from 1 all the way up to 3. So in order to do that, I need to plug my 3 in. So I'm going to have negative 1/3 plus 1 over 3 times 3 to the 3rd power. I just plugged the 3 in there. Nothing too fancy there. Minus, and now I'm going to plug a 1 in, which is going to be negative 1 over 1 plus 1 over, and I'm just going to put 3 in because 1 raised to the anything power is 1, so this is just going to be a 1/3 here, like this. All I did was plug a 3 in and get this, and then plug a 1 in and get this, and you have your minus sign like we always do. Okay, so over here, what I'm going to have is negative 1/3 plus 1 over, and if you put that in your calculator, 3 times 3 to the 3rd, you'll get an 81 out of that, minus negative 1 plus 1/3. That's 1 over 1 is 1, so I just left it like this. And then to keep on going, to go ahead and just expand all this out, what you'll have is negative 1/3 plus 1 over 81. And then distributing this negative 1, you'll have plus a 1, and then minus 1/3. Now take a look at what we've done here. We've got term with a couple of 1/3 in it. We've got a term with 1 over 81, and we've got a term with 1. You can play around with this, finding a common denominator, or you can just put it in your calculator or whatever, and what you will get in the end is 28 over 81. So the common denominator would be 81. 3 goes into 81, obviously. So you could write these as fractions of 81, and you can add them all up and you get that. So notice that even though this looks a lot more complicated, it really isn't. It's just another polynomial with negative exponents. So we do the actual integration exactly the same. It's 1 over 1 plus the exponent, 1 over 1 plus the exponent here. And then from there, it just becomes an exercise in simplification. You got to keep your sign straight. This is negative sign out front because of this. This is a negative 1/3 inside because of that. You've got a minus sign here that could easily trip you up. That's what I'm talking about, keeping your sign straight. So this becomes a plus sign. And then when you plug in your limits of integration in terms of fractions, you know, it can get a little bit messy, but it's really not terribly messy. It's just tedious. Okay, so that's why I'm saying make sure and have all your steps laid out in easy to read form, so that when you're studying, you figure out, you won't be guessing exactly what you were doing. Let's switch gears a little bit and do an integral of a type we haven't done so far. From positive pi over 4 to positive pi over 3. That's the limits of integration. And what we're integrating is sine of t dt. And we want to find out what this is equal to. Now, if you look back not too long ago, I told you what the integral of the sine function is, and that's negative cosine of t. That's the answer. That is the integral of the sine function. And you can find that in your textbook as well. It's just going to be given to you there. And you evaluate that from pi over 4 to pi over 3. Okay? And you might say, well, geez, how is this the integral? If you forget, you could just take the derivative of this, and you should arrive at this. The derivative of cosine, the cosine function itself, is negative sine. Negative sine times negative 1 gives me positive sine. So this is indeed the integral of the sine function. So in order to proceed any further, you need to plug these numbers in. So what you're going to have is negative cosine of pi over 3, that's the upper limit, minus negative cosine evaluated at the lower limit, which is pi over 4. Just like this. Now notice I was, again, very explicit. I carried my negative cosines inside. I didn't try to do anything in my head. I just wrote it down. Okay? So then I ask you the question, what is cosine pi over 3? And you can go back if you don't remember how to do that. You can certainly put it in your calculator. You could also pick up my DVD in trigonometry and pre-calculus. It covers all of this stuff, how to evaluate trigonometric functions in terms of you know, your values of pi here. So that's the trig and pre-calculus tutor. But the answer to this question is the cosine of pi over 3 is the same as cosine of 60 degrees, which is 1/2. So it's 1/2. But I've got a negative sign here, so it's going to be negative 1/2. But the answer to this part of it is positive 1/2 times negative 1 gives me negative 1/2. So I've got that minus, okay, cosine of pi over 4. Again, from looking it up in a table or looking at previous DVDs, this is a positive square root of 2 over 2, but I've got a negative there, so it's negative square root of 2 over 2, like this. So at the end of the day, you're going to have negative 1/2 plus square root of 2 over 2, because you got this distributed in here, which in the end, what you're going to have is square root of 2 minus 1 over 2. And that will be your answer. So you can see, again, it's really not that bad. You've got a couple things to remember on how to actually apply the limits. And the trick is just getting the derivative. And then you just got to make sure and keep your sign straight as you go along to make sure you don't screw up in the end when you plug your values in. And you're using that fundamental theorem of calculus. One more final problem in this section. Integral pi over 6 to pi over 3 of cosecant squared theta d theta. A few minutes ago, I told you that the integral of cosecant squared is the following. This is going to be equal to negative cotangent x. Okay, this is the answer. And it's evaluated from pi over 6 to pi over 3. You can find this in a table of integrals. You could find it, just a few minutes ago in this particular section. I gave you that. And if you wanted to check it, you could take the derivative of the cotangent function, and you'll get negative cosecant squared, but you've got a negative here, so negative times negative gives you positive cosecant squared, and so that's why you got to have a negative cotangent here. Okay, I wanted to do this one because it becomes a little bit interesting when you want to actually apply the limits here. Okay, how would you do that? You would have negative, and don't forget, what is cotangent actually equal to? It's the sine, cotangent function is equal to cosine over sine. By definition, you can look in any trig book or you can look on my pre-cal DVD, and this is the definition of the cotangent function. So what you're going to have here is negative cosine of x over sine of x, and again, you're evaluating at the same limits. I haven't done any of that stuff yet, but I just wanted to make it explicit that cotangent is cosine over sine. You got a negative sign in there. Okay, let's press. So you're going to have negative cosine of pi over 3 divided by sine of pi over 3. That's just evaluating this quantity at the upper limit minus cosine of pi over 6 divided by sine of pi over 6, and that's evaluated at the lower limit. Okay, cosine of pi over 3 is the same thing as cosine 60 degrees, which is 1/2, so I'm going to have 1/2 in the top of this right here. The sine of pi over 3, which is the sine over 60, is the same as the square root of 3 over 2. That's the answer. This is all from trig and pre-calculus. So if you're not comfortable with doing this kind of stuff, you need to go back and review that, because you're going to be doing this all through calculus. You need to be able to do the sine and the cosine and the tangent of the basic angles here. Cosine of pi over 6, which is the same as cosine of 30, is the square root of 3 over 2 in the top here, and then the sine of pi over 6, which is the sine of 30 degrees, is 1/2 here. Again, positive. Okay. So you have these 2's canceling here and these 2's canceling right there, and in the end, what you're going to have, okay, is you're going to have from this term here, you're going to have negative 1 over square root of 3, and over here, you're going to have plus, because negative times negative gives you positive, square root of 3 over 1. So this is basically the answer, negative 1 over square root of 3 plus square root of 3. Now you could beat this into shape, making a common denominator and simplifying that further, but I just wanted to get the point across in how you do the calculus part, which is this right here.